I have an abuela rule in my classes and in my work. And the abuela rule is this: we need to be able to communicate with each other in ways that are understandable to our grandmothers. And I am not saying that we need to water down or distill or somehow dumb down the ideas that we have. But our abuelas carry such wisdom in this world. We do not want to waste their time with jargon when we can just say things simply.
This is High Tech High Unboxed. I'm Alec Patton, and that was the voice of Dr. Rochelle Gutiérrez giving the closing keynote speech at the 2023 Deeper Learning Conference. Rochelle is a professor of curriculum and instruction at the University of Illinois, and her research focuses on mathematics. I had a chance to talk to her at the Deeper Learning Conference, and it was totally fascinating. Here's our conversation. On the most one-sentence level, what should folks know about you?
Folks should know that I come from a long line of activist women who have political clarity and know how to fight for our people and for a better world.
And when you say our people, who's...
Our people, meaning people who've had land stolen from them, people who have been misunderstood, people who have been touched by this grief of diaspora. Really, most of us have been touched by this grief of diaspora where we've been pulled from lands and where we either don't know our own lands for people who came as slaves or people who've been forcefully removed from their lands, and also people who deeply know their connections to lands. But it's this idea that society has not been built in a way that honors all people. And so when I say our people, I'm talking about my people in particular, people who are Chicana, and my ancestral roots are Raramuri, which is from the Copper Canyon region of Mexico.
Okay, thank you. All right, let's go back now. When you think about your childhood, what memories surface when you think about your experience of math as a student?
It's so complex. On the one hand, I have incredibly joyful memories of mathematics growing up, learning sewing through my mother and my grandmother. I think about all of the complex ways that women who sew know how to think about different permutations of colors and bringing things together and thinking about orders of operation and angles. And there's so much that's kind of embedded in this way of making something, and also being in relation to our plant relatives, knowing that, yarn and fiber and thread comes from plants. But as a child, when I was in the gifted program, we did amazing mathematics. I mean, we were working in other bases. We were often adding and subtracting and multiplying in, base 2, base 3, base 8, something else. And this was so playful for me. This felt like it was so much fun. I remember learning about base 2 and thinking, this is great. I would write down on a piece of paper, I'd tell my mom, I want this many cookies, and I'd write 1, 1. And she would look at me like, I'm not going to give you 11 cookies. And I would say, in base 2.
What is 1, 1 in base 2?
So the way that bases work is that base 2 would be like the first digit 1 would represent 1. And then once you get to 2, it's 1, 0 would basically be 2 cookies. And then 1, 1 would be 3 cookies. So I was basically asking for 3 cookies. But when I wrote it down, I would write 1, 1, and she'd be thinking base 10 and I'd be thinking base 2. And I just thought that this was so much power as a child to be able to kind of like play with the rules. And so I had all of these amazing experiences like that where we were doing logic problems and we were working on their bases. We were doing point perspective drawings as part of math class. We were doing, so thinking about like how can you look at a street and then take a point that's either a diminishing point or thinking about like what would need to be the angles for the windows to look like they were actually perpendicular, but they're not going to look like rectangles anymore. Now they're going to have this angled line, right? And so just all of that was so much fun. And that was math class, right? That was what we did in math class. But, then I also had points in my life where, in 7th grade, I had this math teacher who was really strict on rules. And so you were not allowed to say something like 3.6. You had to say 3 6/10. And if you said 3.6, he took out a permanent marker and he put a dot on your forehead. And that was to remind you that you don't say point. Yeah, so imagine as a young girl, as was in middle school, like having somebody put a permanent marker on your forehead. Like this was like such a horrific and traumatic experience for a person. And like how is that supposed to be humane at all for helping people think about what really is just a custom in mathematics, right? That's an aesthetic choice that we took to say 3 and 6/10 so that we can help people understand place value. So we can say we're in a base 10 system. And so when we have something that's after the decimal point, that's tenths, and something that's 2 after, that's hundredths, and something that's thousandths. But that was a choice that was made by somebody in history, in mathematics, that we've followed. And then that was a choice of that one teacher. So my parents, my mother was furious and pulled me out of that math class and put me in a different teacher and tried to get that teacher sanctioned, because there were going to be other parents who didn't know this was happening, or other children who didn't feel that they had any power to stand up to that teacher. But so, there were things like that. There were things like later in my life, I don't have a degree in mathematics, I have a degree in biology. And later in my life, I remember thinking, maybe I need to get a degree in mathematics. Maybe this will help me better be able to explain to mathematicians what I'm talking about when I'm trying to say rehumanizing, or I'm trying to think about these other worlds that we can have in mathematics. So there was the point when I thought, well, maybe I should go get like a master's degree in mathematics. My university will allow me to do it. It'll be free. I can go take courses. But in thinking about that decision, I had to ask myself, when I was looking at the courses I would take, I thought, is this really going to be the mathematics that's going to help me envision another world? Or is this really going to be the mathematics that's going to help me get credentialed by other people and like have this mark of approval that I've also been able to do this thing that we call Western mathematics in math departments that focus on research, right? And so really then I decided, I guess my math story goes into the fact that I had a lot of friends who were mathematicians, and I could learn from them. I could learn from books. I was most interested in the history of mathematics because I thought there's no way that we can reimagine another kind of mathematics if we don't know where we've come from. Currently, the mathematics we're teaching in schools is this Western modern mathematics. I mean, even the mathematics we teach when we say geometry, we're telling students this is geometry. This is Western Euclidean geometry. This is not all the geometries that actually are practiced in the world or that have been practiced over time. So for me, my story has been, it's kind of meandered from like these joyful experiences to these like awful experiences to these questioning myself experiences. And I think that's all part of what many of us go through in mathematics.
The first thing you mentioned was sewing. When did you recognize that as mathematical training and mathematical experience?
Oh my goodness. I would say maybe graduate school. Like I never really thought of that as mathematics. I mean, I thought that this was really cool. My mother encouraged me to make a lot of like small objects for my dolls. And so trying to think about proportions and reasoning and all that would be involved in like having a pattern of something much larger and then trying to reduce it so that it still had the form and the shape and the proportions. I don't think I thought about that because there weren't people around me I think also from an Indigenous perspective, like math isn't this extracted thing. We are in relation to our worlds and we think about pattern and logic and and just our spatial reasonings, structure. Those are all like embedded in kind of everyday ways of how we move through the world. It's not like this thing I'm doing is mathematics now. It's kind of like it's math and it's, storytelling, and math is storytelling, and it's bonding, and it's all these other kinds of these rituals. So I feel like, I don't know, I think maybe when I started to question who gets to decide what counts as mathematics when I was in graduate school, maybe that started making me think about there's all these ways people already do mathematics that we actually just don't sanction.
So, it sounds like you were, mixed experience, but pretty stoked on math. I wasn't asking for cookies in base 2, certainly when I was growing up. So I'm curious, why didn't you study math in college?
So there's 4 children in our family, and I was the third child. And when I got into Stanford University, I did well in math. I took AB and BC Calculus, and at that time there weren't a lot of schools that offered BC Calculus. I was on the math team. I did all the kind of geeky things that you would do. I tutored people a lot of times in math in my free time. But at that time, I felt like the narrative was if you're going to use science or math to do something, you go to med school. I didn't know anybody who was a mathematician. I didn't know anybody who did that kind of work. But a doctor, that was like an identifiable thing. And so I thought, this is what I should be doing. But it really wasn't until I was in my junior year and I was applying to med schools. I was literally had taken MCATs, was applying, was in secondary applications, was all in. And I had to take a class to fulfill one of these other requirements that was not supposed to be for my biology major, because Stanford tries to make you a well-rounded person. And I resisted as much as I could, but there was this one class I had to take that was on art or art in expression or something like that. And I took a class from Elliot Eisner on the artistic development of the child. In that whole class, we fought because I didn't agree with some of the things in the class, and I thought that it assumed certain things about the people. And after the end of the class was ending, he said to me, Rochelle, he said, you're really smart. He said, you're really analytical. And he said, why not try something really hard like education instead of med school or whatever? And it really hit me that why don't I think education is the harder thing to do? Why have I somehow been convinced by people that if you're smart, you go become a doctor? So then I couldn't apply right away to school. It was too late to apply to get a master's degree in education or something like that. So I started teaching in the migrant education program at Stanford. And it was like my light turned on. It was like, this is what I'm supposed to be doing.
And what's that? What's the migrant?
The migrant education program at Stanford was they would bring in students of migrant families for the summer, and we would teach them math and computer science at the time. And that was really where I think for the first time, I thought, God, this is what I do in my free time, and somebody would pay me to do. This is what I love. And so it was really that beautiful experience of being able to be in my community, being able to be with people who looked like me, who both of my parents had grown up picking in fields. And so this just felt like I could pull all my selves together. I could be one person, and I could be doing this work.
All right, I got a couple follow-up questions here. What were you and Elliot Eisner arguing about?
We argued about the readings, sometimes the assumptions that were made about how people experience school. And so I felt like there was this kind of universalistic experience that was presented, students learn in these ways, or students do these kinds of things. And I just thought, God, there's all kinds of ways that people learn. People learn by observing, people learn by dreaming, people learn by singing, by making, and I was kind of like, this feels like we're just kind of stuck in this one person's view of what learning counts as, right? And he was amazing in terms of expanding my views about what does it mean to be somebody who when you are an expert in a field, how you take in different things, you pay attention and you notice different things. At the time, I had done 16 years of ballet, and he was helping me realize that when you go to a ballet performance, what I'm paying attention to might be something different than what somebody next to me is paying attention to. And it's really that level of expertise that makes you focus in on particular things and notice and value and think about what counts as beauty. And so when he was talking about art, he was saying that there's all these different things that come into play about what we find aesthetically pleasing and also what we value in art. And so I felt like I took that idea from him and said, well, aren't we kind of doing that in education? Aren't we also kind of saying there's these aesthetic choices we make in education, and we value certain things and we look for those things in learners, but maybe there's other things that learners are doing that we're missing?
All right, so there's one more piece here, because the narrative that I have is you're going to be a doctor.
Yeah.
And you said, and then what took me into studying how math is taught was taking a class on art education, which one might imagine would lead you naturally to studying how art is taught.
Yeah. Yeah, and people often ask me, well, you have a degree in biology. Why didn't you go to science education? That seems like it makes a more natural connection. I think at the time what I understood, though, was the power of mathematics as it formats our lives. I think I understood that mathematics served as a gatekeeper so that people who I wanted to be able to go into sciences wouldn't be able to do that if they couldn't show that they learned their math in the ways that school sanctions it, right? So I felt like if I'm going to make a big difference in the lives of other people, I'm going to have to address this thing that's mathematics. And it was the thing that I loved doing kind of in my free time.
Thank you for that. I want to take now the abuela rule and tweak it slightly to the teacher rule.
Okay.
If a teacher is listening to this and they're thinking wow, yeah, that makes a lot of sense. I can see that math is like this gatekeeper. I can see that kids have different approaches and that doesn't get honored. What should they be thinking about?
I think that we need to be more explicit with students about how we got to this form of mathematics that we're doing. I feel like we need to be more consistent in offering students opportunities to say, in the 17th century, when we were thinking we were only in two dimensions, we got these Cartesian coordinates, and that helped us think about geometry in these ways. But then once we realized we were on a curved surface and we had different assumptions about the world, then we got to non-Euclidean geometries, right? But how do we help students see that all along, over time, we've made decisions, and those decisions have led to the kinds of things that we value in terms of structure and reasoning and patterns and logics that we call mathematics, but that we could have other things. So when do we give students opportunities both to see that the mathematics that's been created is a reflection of our human practice? It's a reflection of our relations in the world, and seeing that in fact, we've learned many of these patterns from our more than human relatives. So, pine cones and nautilus shells are performing these versions of mathematics that we've learned from. And then how do we offer opportunities for students to say, what if you had different assumptions? What are some different assumptions you would come up with? So, for example, like if we have younger children and we say, and young kids are great because they haven't been locked into this idea that there is one mathematics. They're still in this kind of playful stage of like, you can kind of invent anything that you want, And so like if you said to a kid, we have 4 operations right now that we use in math class. We have addition, we have subtraction, we have multiplication, and we have division. Why don't you come up with a 5th operation for us? What would that operation be? Why would it be useful for you as a learner? What would be its constraints? Would it work with only integers? So, you can get kids into a space where they could be playful and they can say, well, if I'm in this other world where my other world was other bases, right? And so I can imagine if somebody had given me a prompt to say, like, we're doing this thing, what if you wanted to do it differently? And I thought, okay, if I'm in base 2, I'm going to do it in this way. Or if I imagine a world where like maybe we're not on a sphere or a globe, maybe we're in some kind of a like donut shape. It's giving students that opportunity to not only understand the rules and follow the rules, but to break the rules. It's like in music. In music, when you're taught, or I'll use dance as, classical ballet. Like you're taught classical ballet, and it's really, you have to ask who's classics. But classical ballet teaches you a very kind of everything up high, like everything is kind of like in your chest, in your head, and everything is lifted. The lines of your body and everything are lifted up. All the angles of everything that you're doing, they're always, this very kind of upward space. But in other cultures, so my husband's Indian, and like when I think about like dancing with Indian dance, everything is low and it's centered. And so or even in like salsa or bachata or merengue or something else, how are your values of like stomping the ground? So again, thinking about what is our relation to lands, that when we are stomping the grounds, we are literally keeping the momentum going in the cosmos. Like this is part of our relation to lands. This is why we need to be here and loud and stomping and lower, like closer to the ground, right? Not this high upper lifting, whatever. But if that's my way of thinking about the world, and then you tell me to come up with a dance move, I'm not going to be locked in this, like everything has to be airy and uplifted and light and whatever. And so if we think about that mathematically, what could be the ways we could be inviting students to riff off of worlds they can imagine or things that they currently experience, right? And so pointing out for them, like, that makes so much sense that from your world or from where you're coming from, that you would decide that would be a useful thing to do in mathematics. It's kind of like when we think about community knowledge and we think, we've come up with mean, median, and mode as forms of representation in statistics, right? So why those? Might there be some other form of representation that we would want that wouldn't be one of those? What would it be? Why would that form be useful for us mathematically? What would that communicate in a visual, right? Or in a name, so when people say like, oh yeah, the mode that's most often, people understand, oh, that's useful because we might want to know something about why that was a popular thing for people to choose, right? As opposed to the average thing for people to choose, right? Which might not make as much sense. But what would be other things that we might want in mathematics? And so it's this idea of, it's not just, I don't want to say it's just playful, because when I talk about rehumanizing mathematics, I'm talking about centering the very people who have been most harmed by the dehumanizing forms of mathematics in schools. And so that's things like the binary logics that make it seem like a number is either even or it's odd, which goes against two-spirit experience, or people who are queer who recognize that gender is actually very fluid. Our more than human relatives teach us that, black bears and clownfish and all these other relatives who can transform into other genders or multiple genders. Or so I think, it's giving students those opportunities to say, here's a rule, or here's this thing you're going to learn, and now we want to try to expand it. How would you expand it? Because then we're saying, how can students be authors on mathematics rather than just consumers of mathematics? And I think that's a big piece of how we think about changing math itself, not just who gets to play this game of mathematics. Got it.
I think you kind of touched on this already, but I read that you use the phrase a spiritual turn in mathematics education. What does that mean? Unpack that.
In 2010, I wrote this piece. It didn't get published till 2013 because of the way that journals work. But I published this piece called The Sociopolitical Turn. And I was saying that we needed to be more conscious of issues of identity and power in mathematics. And I wasn't the only one talking about this. So I was really just pointing it out as this is a turn our field is making, right? But I feel like now we're in a position, and in 2002, actually, I wrote a piece that was talking about how we need to have other relationships between humans, mathematics, and the planet. But at the time, I didn't have like an actual thing to point to. And so I feel like we're in a spiritual turn now because we're in a moment where people are recognizing that their relations to the world, I would say, are more than human relatives, but other people might say, nature, or they might say our living world, or they might use whatever terms kind of make sense for them. That there's a space for us to recognize that we need to be in better relation with each other as humans in terms of what's going on politically in the world. And we need to be in better relations with lands and waters and skies, and because of what's going on with climate change, and there's kind of an awakening. But I also think that this is a time when we're recognizing globally that we've all been affected by this idea, what I was saying, this kind of grief of diaspora. We've all been taken from places, and so we've been scattered. And in all different traditions, we have ways of talking about finding the unity in the world and bringing things back together. And so I feel like that's the spiritual turn. The spiritual turn, it's not about religion. It's about how do I come to see a version of you and me and a version of me and you. So I feel like the spiritual part is saying, how do we think about seeing each other as kin, bringing each other together? And the role of mathematics in that is, if mathematics is really just about pattern and structure and logic, how are we pattern? How are we pattern in the world? How are you, again, like me but not me? How are we structured together? How do we have opportunities for students to see each other as, oh, the way that you're approaching that problem is like the way I was approaching this problem, but then it's kind of not the way I was approaching this problem. And so kind of, that's really interesting the way you are doing it, like just like me, but kind of not like me. And somebody in another part of the world is also doing something like that. And so spiritually, how do we come to see this work as about attachment to each other and not just about problem solving in either school systems or even problem solving in technology spaces?
Yeah, it strikes me that it feels like a lot of this aligns with your arguments with Elliot Eisner, that like, it kind of feels like rather than thinking about there's a universal that things align to or not, you're kind of saying there's a multitude of different ways, but they're all connected.
Yes. And I would say that's Nepantla, because Nepantla it's an Aztec word that basically means kind of neither and both at the same time, and so it's embracing that contradiction. It's saying that mathematics is both incredibly universal and not universal at the same time, right? And I think we have universal shared things that we experience in the world, and so in terms of pattern and structure and logic, and so that unites us. But also we know that mathematics has arisen through place-based ways of being in the world, right? So different people have developed attending to certain kinds of patterns based on whether you're on the plains or whether you're in a Saharan space or whether you're in in mountainous regions or whether you've got lots of water around you or whatever. That's going to call our attention to different kinds of things and for different purposes. And that doesn't mean that somebody's mathematics is better than somebody else's mathematics, but it's also, it's recognizing that tension that like we actually all do the same mathematics and then we don't do the same mathematics. And I just want to make a plug for my friend Linda Furuto, who runs the ethnomathematics program at the University of Hawaii. So only a few years ago did we get a full-fledged program where you can get a master's degree in ethnomathematics. I think there's people who have never even heard of that word, ethnomathematics, but it's basically just pointing out that there are many mathematics that are practiced throughout the world. And ethnomathematics is a tradition that goes back to 1985 with Ubi de Ambrosio. So I don't want to make it sound like any of these ideas I'm bringing up are brand new, but I think that we're in a point right now where I think we're just in a different moment where people are willing to understand and take up these ideas in ways that maybe they weren't 10 years ago.
Yeah. We are at 30 minutes.
Yes.
Is it okay if I have a couple other things I'd love to ask, but we can also stop it here if you got to get going.
Let's just maybe take one more.
Yeah, no problem. Okay, this is sort of a double question, but recommended reading.
So I would say this is your creative insubordination.
Yeah.
So I said one more, and you're like, okay, I have one question with two parts.
You can choose either one of these. Is recommended reading and or recommended board game.
Oh, wow. Oh my gosh. Just one board game? Okay, let's recommended reading. A recommended reading for whom? For teachers? For people just entering this?
For teachers, and just like when you're going like, hey, you know what? More people should read this book.
Yeah, and I feel like, I don't know that educators have as much time to read books as they have time to read shorter things.
This is true.
I would say maybe read I have a piece that came out in Joom, the Journal of Urban Mathematics Education, in 2013. This was a long time ago, but I'm kind of pointing out what's political about everything we do as math teachers. It's like a 7-page article. It's really short, and somebody could just pick that up. Or there's the introduction to the Rehumanizing Mathematics for Black, Indigenous, and Latinx students. That's like a 5-page introduction that gets people to understand a little bit about what is this Rehumanizing Mathematics. So I feel like those are kind of like short, easy ways into something.
Great. Well, thank you so much.
Yeah, thank you for having me.
Awesome.
This has been fun.
Super
Take care.
Fun. High Tech High Unboxed is hosted and edited by me, Alec Patton. Our theme music is by Brother Herschel. Huge thanks to Rochelle Gutiérrez for taking the time to talk about her work. You can find links to her recommended reading in the show notes. Thanks for listening.